How to accurately measure thermal conductivity. Have you ever wondered how scientists and engineers determine how well different materials conduct heat? Measuring thermal conductivity is essential for understanding heat transfer and energy efficiency. Let's break down how to do this accurately. First, thermal conductivity is a property that tells us how well heat moves through a material. To measure it correctly, you need to choose the right method based on the type of material you have, its size, and how precise you want the results to be. There are two main categories of measurement techniques: steady-state methods and transient methods. Steady-state methods are used when the heat flow through the material is constant. One of the most common techniques is the guarded hot plate method. In this method, a sample is placed between two plates that are at different temperatures. Once the heat flow stabilizes, you can measure it and calculate thermal conductivity using Fourier's law of heat conduction. While this method is very accurate, it can take some time and requires good insulation to prevent heat loss. On the other hand, transient methods measure thermal conductivity by looking at how temperature changes over time after applying a brief heat pulse. These methods are generally quicker and can work with a variety of materials, including solids, liquids, pastes, and powders. One popular transient method is the transient hot wire method. In this technique, a thin wire is placed in the sample and heated with an electric current. As the wire heats up, its electrical resistance changes with temperature. By tracking this change over time, you can calculate the thermal conductivity of liquids or phase change materials. This method is particularly useful for fluids and powders. Another effective transient method is the transient plane source method. Here, a flat sensor with a heating element is placed between two halves of the sample. As the sensor heats up, the temperature response is recorded over time, allowing for the calculation of thermal conductivity, thermal diffusivity, and specific heat capacity. This method works well for solids, pastes, and thin films. Lastly, there is the laser flash method. In this approach, a short laser pulse heats one side of a thin sample, and the temperature rise on the opposite side is monitored. This method is mainly used for solids and thin films and provides thermal diffusivity, which can be combined with density and specific heat to find thermal conductivity. For accurate measurements, consider these practical tips. Ensure your sample is uniform and the right size for the method you choose. Some methods requiring larger volumes, while others work better with thin films or powders. Also, minimize heat losses by using good insulation and controlled environments. Using reference materials with known thermal conductivity can help validate your measurements. Lastly, remember that some methods are better suited for specific materials. For example, the transient hot wire method is great for liquids, while the guarded hot plate method excels with solids. By selecting the right measurement technique and controlling the experimental conditions, you can accurately measure thermal conductivity. This knowledge is vital in fields like construction, electronics, and materials science, helping us understand how heat transfer works in various applications.